Classification of turning points. The first derivative test. Essentially, this is saying that let x be equal to a be a turning point of y of the function y is equal to f of x. We can classify a turning point as a maximum or a minimum point by using the sign of dy by dx before and after the turning point. All right, so essentially what this table is showing is that if a point is a maximum turning point, the gradient before the point is going to be positive, the gradient after the point is going to be negative. If a turning point is a minimum turning point, the gradient before the turning point is going to be negative, and the gradient after the turning point is going to be positive. And the gradient at the turning point is equal to 0, 0. So again, for a turning point to be a maximum turning point, the range of the gradient, or the sign of the gradient before and after the turning point is positive and then negative. For it to be minimum, for it to be a minimum turning point, the sign of the gradient before the turning point has to be minimum, and the sign after the turning point has to be a maximum. If if the gradient before and after is the same, what you have is a point of inflection. So again, maximum turning point, you have a positive gradient, 0, and then negative gradient. Minimum turning point, negative gradient, 0, and then positive gradient. Let's have a look at example 16. Example 16 says, find and classify the stationary points of y is equal to 3x squared plus 2x minus 1. All right, this is a quadratic expression. It's a positive quadratic expression, meaning that the x squared term is positive. This function should have a minimum turning point. All right. The graph of a quadratic function is a parabola, and in this instance, the parabola would look like this. It should be a smile. If it's a smile, you're going to have a minimum turning point. All right, let's see if the calculus supports that. We have y is equal to 3x squared plus 2x minus 1. So we're going to have to find and classify the turning point. I'm going to say dy by dx is equal to 6x plus 2. dy by dx is equal to 6x plus 2. Now at the stationary point, dy by dx is equal to 0. So therefore 6x plus 2 is equal to 0. 6x is equal to minus 2. Divide both sides by 6. X is equal to minus 1/3. So x is equal to minus 1/3 is the value of x at the stationary point. Let's get the value of y. I'm guessing I can say when x is equal to minus 1/3, y would be equal to, what was it? All right, let's go back. All right, I'm going back just to see the equation. 3x squared plus 2x minus 1. 3x squared plus 2x minus 1. So it's 3x squared plus 2x minus 1. Alright, so this is going to be 3 times 1 over 9 minus 2 over 3 minus 1. So this is going to be 1/3 minus 2/3 minus 3 over 3. Alright, so this is going to be minus 4 over 3 minus 4 over 3. So, um, x being what? Minus 1/3 and y being minus 4 over 3 is the turning point. Alright, so we're asked to what? Find and classify the turning point. So find turning point. Now let's work on classifying the turning point. Using the first derivative test, we have dy by dx, I think was equal to what? Was equal to 6x 6x plus 2. So dy by dx is 6x plus 2. X is equal to minus 1/3 is the turning point. So let's use a value before x. Before x is equal to minus 1/3. Let us say when x is equal to minus 1, dy by dx would be 6 times minus 1 plus 2, which is minus 4. So dy before the turning point, dy by dx is what? Is negative. Let's choose a value of x after the turning point. We can choose when x is 0. When x is equal to 0, dy by dx would be equal to 6 times 0 plus 2, which is equal to positive 2. So just before x is equal to minus 1/3, just before x is equal to minus 1/3, what we have is the gradient is first negative. So we have a negative gradient. At x is equal to minus 1/3, the gradient is 0. And just after it, so this is supposed to be positive 2. Just after x is equal to minus 1/3, the gradient is positive. So we have a negative gradient, then what? 0 gradient, and then what? Positive gradient. So I can say from that I can see that what I'm dealing with is a minimum turning point. So therefore, minus 1/3 minus 4 over 3 is a minimum turning point. Alright, we were asked to find and classify. Classify means to say if it is maximum or minimum.